A very good day to Dr. Ali. We are from Group C in Calculus 2. Today we would like to present the application of integration in kinematics. Firstly, we have to introduce our team members. Firstly is myself, Mabel Ong Sherry with the metric number of 27652. Next is Janice Lim Si with the metric number of 277059. Next, Ba Chang Jun with the metric number of 278953. And lastly is Gui Shen Wei with the metric number of 279569.
My name is Ba Chang Jun and I would like to present key concept. Project 1 is kinematic, and kinematic is to analyze the equation of calculating displacement, velocity, acceleration, and time. Project 2 is projectile. Projectile is to understand the mechanics of horizontally launched projectiles. Next, method. Calculus is an advanced maths topic, but it makes deriving equation of motion in kinematics. For the first motion, by definition, acceleration is the first derivative of velocity with respect to time. Take the operation in that definition and reverse it. Instead of differentiating velocity to find acceleration, integrate acceleration to find velocity. This gives us the velocity-time equation. If we assume acceleration is constant, we get the so-called first equation of motion. This is the step for the first motion. For the second motion, by definition, velocity is the first derivative of position with respect to time. Reverse this operation. Instead of differentiating position to find velocity, integrate velocity to find position. This gives us the position-time equation for constant acceleration, also known as the second equation of motion. This is the step for the second motion. For the third motion, there is no obvious way to derive the third equation of motion using calculus. The third equation of motion relates velocity to position. We get one derivative equal to acceleration and another derivative equal to the inverse of velocity. Separation of variable. Get things that are similar together and integrate them. Here what we get when acceleration is constant. This is the step for the third motion.
Hi, my name is Janice Lim. Next, let's look at the example of kinematics. Suppose we have a train accelerating at a is equal to 2t meter per second square during the interval t is equal to 2 and 4. If we know it has a velocity of 20 meter per second and t is equal to 2, how fast is it going at t is equal to 4 and how far did it go during this interval? How fast? It means the question wants us to find the velocity. Since acceleration is the first derivative of velocity, so we just let a is equal to dv by dt. And then we know a is equal to 2t. Then we adjust the place, let dv is equal to 2t dt. If we want to find the velocity, we need to do the integration. Then we just integrate the both sides, then sub their limits. Then finally we can get v, that is velocity is equal to t squared plus 16. Then when t is equal to 4, velocity is equal to 32 meter per second. Next, how far did it go during this interval? How far means the question wants to find the distance. As we know as, velocity is the first derivative of position with respect to time. So we just let v is equal to ds by dt. From the last question, we got v is equal to t squared plus 16. Then we adjust the place, let ds is equal to t squared plus 16 dt. If we want to find the distance, we need to do integration. So we just integrate both sides and sub their limit. Finally, we can get s, that is distance, is equal to t cubed per 3 plus 16t minus 104 per 3. Then when t is equal to 4, s is equal to 50.67 meters. Then we know 50.67 meters they go during this interval.
For the projectile motion, based on the graph, a small object with mass m being shot at starting at an initial height y0 with initial velocity v0 when t equal to 0. So we start with an equation f equal to ma and the second equation f equal to negative wj. The second equation has a negative sign because it's moving downwards. As we know, weight equal to mass times acceleration, hence f equal to negative mgj, and the velocity of motion equal to acceleration plus initial velocity. So vt equal to integrate a dt means that integrate of negative gj dt, so we get answer negative gdj plus c. Since c is the initial velocity when t equal to 0, vt equal to negative gdj plus v0. For the position vector pt equal to integrate vt dt, so means that integrate of negative gdj plus v0 dt, so we get the answer negative gt square over 2 times j plus v0t plus c. So we simplify as in bracket negative gt square over 2 plus y0 times j plus v.
My name is Mabel Mushewe and I will present examples on projectiles. This question is based on a projectile produced when a cannon is fired. There are 4 questions needed to be solved. Firstly is to find the initial position vector equation. Second is to determine the maximum height. Next to find the range of projectile, and lastly to determine the final velocity when the cannon lands on the ground. To find the initial position vector equation, by using the projectile position formula, which is the position vector equals to negative gt square over 2 plus initial y in the y direction plus initial vector velocity multiplied by t. At the initial position, we know that the initial height equals to 0 because the cannon has not been fired. The cannon is fired at the angle of 45 degrees. To get the resultant angle, by substituting the values into the equation is separated into 2 directions, which is the x direction and the y direction. In this formula, we can see that 100 square root 2t represents the x direction and negative gt square over 2 plus 100 square root 2t is the y direction. Next, to find the maximum height, we know that the velocity equals to differentiation of position over time. At the maximum height, the y direction equals to 0 because the cannon is not going any further upwards. By substituting the velocity of y direction equals to 0, we will get the time when the cannon reaches the maximum height is 14.43 seconds. By substituting the time 14.43 seconds back into the position vector equation, we will get the maximum height of the projectile is 1020 meters. Next, to find the range of the projectile. To reach the end of the projectile, the time taken is double the time, which is 28.86 seconds. Thus, distance from the initial position to the final position is 4082 meters. We can conclude that at time t 28.86 seconds, the range of the projectile is 4082 meters. Lastly, to find the velocity of the cannon lands on the ground, substitute the time t equals to 28.86 seconds into the velocity equation. We can get the velocity equation equals to 141.42 in the x direction and negative 141.41 in the y direction. It is a negative value for y direction because the cannon is falling downwards.